learned just back there. We already learned how to do integrals with your calculator, but for people who aren't here or any of this, we already know that this integral, this makes what shape? I gave this one yesterday. This makes a semicircle, and so we're going to find half the area of a circle with a radius of 3. And so if you do this on your calculator, there's a couple different ways that you can plug it into your calculator. First way is to graph the function, and then that's kind of, I think, the easiest way and also kind of the best way. It says, what does it say? 6-2, continued. Numeric, that means with the calculator, integration, and integrals of discontinuous functions. Because a lot of times you'll get a function that you can't either do by looking at the graph of it, and you're trying to take the integral of it, or you'll get one that where the function itself is very, very complicated, and it would be really hard to take the antiderivative of it when you do integration. And so sometimes you just have to use numeric integration. With this one, I would do it graphically, but I'll give you one that would be more difficult to do it either algebraically or graphically. So say I plug in this function, clear, and first I have to put in the function. So I'm going to go, it's just the square roots. Do I need parentheses? No, I don't. So I'm just going to go second square root. Is that it? Square root of 9 minus x squared. No. X squared. And close the parentheses. Okay? And then if I hit graph, I should see a semicircle or part of a semicircle. And the reason you don't see this part is because, you know, it only has so many pixels, and that would be pretty vertical there. So that's why you're not seeing the rest of the curve. And then all you have to do, like I showed you, second calc, integral, which is number 7, and then
You always hit it too much.
Hey. I'll just hit 7. Okay. And I'll say lower bound, so I'm going to go from -3, and then I hit enter, get rid of this, and I hit enter, go away, and I hit enter, and then I hit +3, it'll ask me upper limit, +3, and then I hit enter, and it should not only find the integral, but fill it in and show you what it represents. And it looks like my answer is about 14.13, and hopefully that's about 9 pi over 2, which we showed you yesterday, right? Because that's the area of that semicircle. Is that 9 pi over 2? Is that about 14? Yes? So that's about the same. Sometimes you'll get functions that aren't as nice as that one to integrate. For instance, you might see the function 0 to 5 of e to the negative x squared times dx. Okay? And that one, even though you, some of you know that you could do anti-differentiation and do the fundamental theorem, this one is kind of really hard to do anti-differentiation on. I think you have to do like integration by parts, which you won't learn until later on. Okay, so this one is not as straightforward to find what you took the derivative of to get that integral. And so I would do that one graphically. Let's see if I can plug that in. E to the negative x squared y equals e is above the log key, natural log key. E to the negative, is it negative x squared or negative x squared. Am I done? Just like that. And if you graph, I don't think that's right because that's gonna, I think I want to put the negative out. I don't think I want parentheses because I want to square it and then I want to make it negative. Okay, I don't want to take the negative value and then square it because there's no parentheses here. So I'm going to get rid of that parentheses. So part of the challenge is making sure you put it into the calculator correctly. Oops. Okay. Oh, it puts it. Well, let me get rid of those parentheses. Let's try again. Y equals second natural log E. I guess it won't let me get rid of that.
Just put a negative and then another parenthesis.
Yeah, maybe that's what I need to do. Negative parentheses. It does give it the same answer. Because this should be it should look something, I think, like this, kind of like that. Does it look like that? Yeah? Okay. So if I put that in, and so y equals e to the, so I guess we don't have to worry about two sets of numbers. To the negative x squared, and close my parentheses, I get a graph that looks like that, kind of, and I want to integrate that from 0 to 5. And so what you might want to do, change your window, because this is a trig window. I'm going to go zoom 6, get a better window. Oh, that's not a better window, is it? Is that the right?
I think it's zoom 7.
Zoom 7? Window. From negative 10 to 10. Let's just change it to,
You just did zoom standard.
let's change it from like 0, well, let's change it from negative 1. Because you got to make sure that you're,
Got a negative 1 there.
I know, I do. You have to make sure that your window is big enough for your limits of integration, right? And since e to the x, it crosses the x-axis at 0, 1, e to the negative x squared is also going to cross at 1, I believe. So I'm just going to set this up to, I'm going to go from, I'm just going to put a negative 1 in, oh, negative. I'm going to put a negative 1 in here. And I'm going to set this up to 2. And then I should get a pretty good picture of my graph. So you kind of have to have some idea of what your graph looks like before you do it. And it looks like it hits, does it actually hit the x-axis? If I plug in a big number, do I get a 0 on the x-axis? So, okay? So I'm going to show you another way to do it, okay? So you could go, I'm going to go second quit, and if you hit clear, and you go down to math 9, which is, math 9 is finite integral, okay? And then you hit bars, y bars, y bars, function y1, comma, x, comma, 0, comma,
What do you do?
What?
It shows up.
Why is it?
okay?
Like mine shows up like this.
Oh, then you're in the math type mode. You just put the 0 down here and the 5 up there, and your function in there. And yeah, if you're in that other mode, you could either change it to classic mode, or you could do it this way. And then it calculates the area under that curve. Okay? Questions about that? Or you can do it the last way. So that's how you do numerical integrals. Any question on that?
Is that all?
Okay. No. Then we have discontinuous. Discontinuous integrals of discontinuous functions, which I already wrote, so I'm not going to write it again. Okay, so this is fast. So say you have something like you want to do the integral from -1 to 2 of x, which you might. I've seen these before on AP test questions and on my test questions. And they say find this without a calculator. Without a calculator.
What?
Yep. Could you do that?
No. No.
So, you should be able to graph this. This function I told you at the beginning of the year, right, when we were talking about limits, this function comes up a lot, okay? So if you make a little table of values, like x, y, and I plug in some numbers, like -3, -2, -1, if I plug in a negative number, what do I get out here if I plug in -3? Not 1, -1, right? So I get -1. If I plug in -2, I also get -1. If I plug in -1, I also get -1, right? It's undefined at 0, right? Undefined because the denominator would be 0, okay? Then what happens when I plug in numbers to the top? I get positive numbers, right? 1, 2, 2, 3, 3. I get 2, 1, and 3, 1, right? So what this graph, write what you say, okay? So this graph looks like, where this is 1, it looks like, watch this, it looks like this in this direction, right? And it looks like this in this direction. Okay? Where this is a hole right there, where this is 1 and this is -1. So how would I find the integral? Even though the definition for finding an integral, come on, stop already, all right? I can't take it anymore. Put them away. You guys. Okay, so how do I find the area between these curves? How would I find that area, young men? Could you tell me?
Wouldn't it just be like finding the, wouldn't they always just equal 0 actually? Because it's one of them's negative and one of them's positive.
Well, not if I'm going from -1 to 2. I go from -1 up to 2, like that, right? And so so I'm finding this area, and I'm finding this area, right? And if this is 2, so how much is this area right there?
Yes.
Positive 2. And how much would this integral from -1 up to 0 be? Not positive 1. The area would be 1, but what would be the value of the integral of this function, the integral of f from -1 up to 0? What would that be? That would be, that dx would be, that would be -1. So I add -1 plus 2 together, and I get that this is equal to 1. All right? So you might want to confirm that with your graphing calculator, and it will do it for you. But that's not the way I or someone on a AP test would ask you to do that. And so if I go to y equals, and you could get the absolute value sign from math, I think. Math. And where is it? Here? There. You go over to here. There's the absolute value. It doesn't have the actual brackets. And so if I go x like that, and then I put like that x, and then I hit graph, my window's kind of messed up, but you can see that it actually graphs that function. Let me change my window so I could go to -1 at least. Let's just change the x-min to, I don't know, -2. And then I'll hit graph. And then I'm going to find the integral from second calc 7 from -1 up to 2. And if you hit enter, it shades it in for you, hopefully, and it gives you the value. And it says that the value is 1.001416. Why is that? I'm not sure why it gives you that, but I think because it's actually adding up, just like it does with derivatives, integral, when it does it on your calculator, it's adding up rectangles with a width of 0.01, but you would think if those rectangles it would still be the same, right? Okay. So I'm not sure why it's giving you that, but I guess because you can't get infinitely many rectangles. So but I think I'm not sure.
Those are rectangles.
Yeah, those are rectangles themselves. So maybe the calculator's just kind of stupid. I don't know. Okay. One more problem, and then well, actually, 2 more things you might see. So what if I have an integral like this, 0 to 3 of x squared minus 4 over x dx. Whoops, I messed up x minus 2 on the button. Do you think you could be a little, turn off your music, whoever's music is there?
No, we hear that too.
Oh, that's your phone. Oh. Right? Do you want me special extended dense mix? No, we're not gonna listen to that. All right. So anyway, so if I did this graph has a hole in it, because if I factor the top, I have x minus 2 times x plus 2, x plus 2 over x. Here, can you make it stop? Thank you. All right, and then so if I cross these out, I have a hole. Remember, if you can cancel something out, you have a hole at 2, 4. You guys understand why that? Remember that from pre-calc? So you'd have a hole in the graph. So if I tried to find this graphically, it just looks exactly like the line y equals x plus 2, except it has a hole at the point 2, 4. There's a hole in the graph at that point. All right? And so they're asking to find the integral from 0 to 3, which is this right there. And it's the area under the curve. So you could still find the integral even though there's a hole in the graph at that point. And you would just do it by finding trapezoids, because this would, if I plug in 0 in here, I get out, not 0. If I plug in 3 in here, I get out 5. So this is the point 3, 5 up here. What?
How do you know the y value is 4?
How do I know the y value is 4? Because if I take 2 and put it in here, like 2 plus 2 is 4, right? And because this equation looks exactly like y equals x plus 2, except where you have a hole in the graph. Okay, but the hole doesn't really matter, but you might need to cancel out that hole to determine what the graph looks like. Okay? And then it just looks like this, and the hole doesn't really matter because it's infinitely small anyway. So if I'm finding the area of this is 3. And when I plug in 0, I get out 2. So I can find 0, 2. So I can find the area of that using trapezoids by going 5 plus 2 divided by 2 times the height, which is 3. And so if you did this on your calculator, you get 7 times 3 divided by 2, which is 10.5. But you should be able to do it without a calculator. Good. Last one they talk about is, and this is the last thing, they talk about this greatest integer function. So what if you want to find the greatest integer function from 0 to 0 to 5 and in the book they go like this: int x dx. Sometimes they would write this as the integral from 0 to 5 of this thing. Okay, that means the greatest integer function. You should be kind of familiar with that because they like that one because it has discontinuities and stuff. And so if you graph that greatest integer function, it goes like this, and then it jumps at every integer. So, and it jumps up here to at 1, and then it goes over here, and it jumps up at 2 to here, and then it jumps up at 3 to jumps up to here at 3. Let's do the greatest integer from 0 to 3. 0 to 5 is too much, I think. So now let's do 0 to 5. 0 to 5. And so then it jumps up to 3, and it goes like this, and then it would jump up right at 3, then at 4 it jumps up to 4, and then at, hey, that looks pretty good for a freehand, doesn't it? And then over here it jumps up to 5. That looks like that. So how do I find the area under that curve? Because I'm not sure your calculator would do it. What's the area under this? So if I want to find from 0 to 5, all I have to do is add up this rectangle plus this rectangle plus this rectangle plus this rectangle, right? What's the area of this rectangle? What's the area of this rectangle? What's the area of this rectangle? How much is that? 3, 6, 10. See? Isn't that cool? Kind of cool. And your calculator will actually do that one for you too, if you wanted to. And the way you would do that, plug that in. You have to go to the same place, I think. To math, number, and then there's int, number 5. And integer of x not divided by x. I wonder what that would look like. Integer of x divided by x. You can play with that if you want to. But if you graph it, there it is. Oh, I have to make my window go up higher. So change my y max to, let's just change it to 6. Make sure I hit it. And then let's go second, or let's quit. Let's hit graph again. And then it looks really cool if you do the integral of that from 0 to 5. 0, and then 5, and you get a staircase. Whoa, isn't that cool? Okay, all right. So anyway, so that's that, and that's all you got to do today. For those of you who are here, not here, the homework is on my website. Here, I'll bring it up, and there's also an AP problem that you can download off my website, which you can do, and it's going to be graded somewhat for accuracy. So you'll get a completion grade, an accuracy grade, and calculus BC assignments. There you go. Same section. Whoa, what's that doing? And AP free response. I think it should be number 3, but I thought we had 4. We've only had 2. so far. So if you click on that link, you'll get the AP problem, but this is the homework right here. And those of you who are in class, I'll give you the free response problem. And you can get started. All right? There you go. Have fun.
I don't think that the link works.
It doesn't work.